Welcome. This is session 462 on the Trusted Platform Module, specifically building hardware-based security using the TPM. I'm Rob Spiger. I'm a senior program manager from Microsoft.
I'm Stefan Thom. I'm a software developer on the platform integrity team and also in Windows security.
We're very excited to be here. We're representing a fairly large team back in Redmond, and we appreciate you coming to our talk. So the agenda for this session is to cover what security goals we have for Windows 8 related to the Trusted Platform Module and hardware, and also talk about a little bit of background for Trusted Platform Module basics and how we've improved the boot process in terms of security using the TPM and hardware-based security. Cover other features in Windows that use the TPM. Cover how provisioning happens in Windows 8 and how the user controls the TPM. And then we'll talk also a little bit about TPM hardware evolution. And we will start out, though, by showing a short demo. And we're going to take questions at the end. So please hold your questions till then. So the demo we want to show is a very simple demo. It's very short. It just basically shows using certificates for like an online banking scenario or another scenario where you want to have high security and a client doing authentication with a website. We're going to go through the demo quickly, and then we'll come back at the end and we'll go through the demo in more detail, and we'll talk about the technology that's going on behind it, as well as what the hardware platform is used for it. So before we begin the demo, quick show of hands. Who has a Windows 8 system with the TPM?
Windows 8? Really? Windows 8?
They just got
okay.
systems yesterday, right? Who has a Windows 8 system? Who has a Windows 8 system with a TPM? Excellent. So you guys, some of you, it appears, have explored your new machine that you got yesterday and it noticed it does have a TPM. Did you also notice the TPM state? No? Okay. You may want to go look at that after this presentation. So I need you to turn around for a moment. He loves the TPM. He loves applications that use the TPM. How many of you have written a TPM-based application?
That's almost everybody, right?
Don't look. Don't look. OK. Now keep your hands up. How many of you deployed a TPM-based application?
That's almost more than before, right? That's
a lot.
Wow.
OK. You can turn back around now. Thanks.
Wow. I'm impressed.
Right. Back to our demo. So certificate authentication.
There we go. So what we see here is standard IE with a certificate picker. We're about to establish an SSL connection to a server who requires a client-side certificate. All this is really nothing new. We have this in Windows for quite a while. IE will show me all certificates that will suffice for this authentication. We're going to pick my certificate in this case. It's issued by an enterprise CA. And since when we applied for the certificate template required that there's high protection required for the key, we have to specifically endorse the use of this key. We're going to do this and authorize the request, and we get the IE side up. This is the first part of the demo.
Thanks. As we said, it was quick. So just to set the stage for these security features, we've got a world today where there's a significant amount of cybercrime going on. It's trying to steal data for monetary gain. There's also a lot of concern about cybercrime in terms of, will my machine be infected or not? People worry about it, from governments to your mother and everyone in between. There's also a lot of socially engineered attacks that attempt to install themselves on a system, especially for users running with administrative rights. And there have been more and more press coverage recently about bootkit and rootkit attacks that infect systems and tamper with boot logs to avoid detection. So given this context, we thought about our security goals for Windows 8. If you've got things out there like Stuxnet worms or Lurian viruses or things like that, there's a lot of things we need to address. And what we'd like to make sure of is that Windows 8 is a trusted platform for all kinds of scenarios, for consumers, businesses, enterprises. And we'd like to leverage hardware-based security that comes on customer systems to be able to help solve those problems that exist today. So we'd like anti-malware products to be more effective, and we'd like the system compromise from malware to be greatly reduced, as well as the ability for anti-malware products to reliably detect and remove malware. And in many cases, that requires providing new APIs and tools for them to do that. We'd also like customers to benefit from hardware-based security like a TPM that's on their system. So just to give people a little background on the Trusted Platform Module, it's a passive device that's on the system that receives commands and returns responses. It also does things that are cryptographic functions, like it will create keys, it will do things with those keys. The specs are published by the Trusted Computing Group. Currently, there's a TPM 1.2 spec out there that was published by the Trusted Computing Group for the TCG. And it's an ISO standard currently, so it's a global standard, an open standard. And today, you'll generally find business laptops have a TPM 1.2 on them. The TCG is also working on a TPM next specification that's supposed to address some of the shortcomings of TPM 1.2, like the fact that it only supports SHA-1 or RSA algorithms. One of the other things about a TPM is you can't just buy a TPM and place it on a system and have security. There's really an interaction between the firmware and the TPM on a system that provide the security. During the boot process, firmware on a system with the TPM records measurements of what's running during the boot process. Those measurements stay in the TPM. They're reset on every fresh boot of the system. And even if something malicious runs later, because the measurements are in a TPM, malicious software that runs in an OS environment or a firmware environment or a UEFI environment is unable to tamper with those measurements that have been recorded. So you really have an isolated environment that's separate from the OS, that's doing specific security functions like holding measurements or signing what the current measurement values are. The other thing the TPM can do is it can create keys. Those keys can have specific usage policy. So only if the right boot measurements are present on the system currently can a given key be used. And an example of the use of this today is BitLocker for Windows 7, which can be configured to use the TPM and is unable to access the volume encryption key if the boot components have been tampered with. So that was the background piece. What we're doing in Windows 8 is we're using this to improve security during the boot process. There is a feature in Windows 8 called Secured Boot, and it has three main components. It has Secure Boot, which is a UEFI term from the UEFI specification. And basically what that does is it provides the ability for firmware to enforce policy about what things run in the pre-boot environment. The second piece is early launch anti-malware, where we'll start anti-malware software as the first third-party code that runs on the system within the OS, and we'll let it enforce policy over other components. And then the third piece is measured boot, where boot measurements happen during the boot process, are recorded in the TPM, and can be used as evidence later to prove the health of a client. Taking a closer look at UEFI Secure Boot, if you think about existing boot processes today, you've got conventional BIOS systems out there in the ecosystem. Those have generally proprietary implementations of what the BIOS code is, but overall, they will generally run any OS loader code that's present on the boot device. And so you start out with a situation where malware is able to install itself and be launched before the OS potentially. With UEFI 2.3.1 and a native UEFI boot, where it doesn't emulate a conventional BIOS, you can have the OEM set firmware policy using features in the UEFI 2.3.1 specification, so it only launches certain OS loaders. And we envision hardware for Windows 8 being configured to permit the launch of Windows 8, because it's a trustworthy OS loader, and potentially other OSs as determined by the OEM. But the important point here is there's validation of the OS loader component. Instead of launching any OS loader code, the firmware validates it and makes sure it's on a list of allowable components to launch in the pre-boot environment. The net effect is malware can't switch itself to become the bootloader. This feature doesn't necessarily use the TPM, but it does require native UEFI boot, and we expect that this should be available on new systems in the not too distant future. The second piece of the secured boot feature is the early launch of anti-malware software. If you look at existing anti-malware products today in an OS like Windows 7, they are launched after the OS loader starts boot critical drivers, like the storage driver, which permits access to the hard drive, and other things that start very early. Even if an anti-malware product is able to configure itself to start sooner, there aren't any APIs or ways for itself to be able to control and enforce policy of other third-party code that starts later. This creates a problem where malware is able to install itself as a rootkit in the OS. With the early launch of anti-malware software and secured boot, the OS only allows signed anti-malware products to start as the first third-party code on the system. There are new APIs and capabilities for these anti-malware products to be able to enforce their policy on boot critical drivers. The expectation is they'll start out with some small policy information and be able to use that on boot critical drivers, and then once the storage driver is available, be able to access their larger database of virus signatures to do things that anti-malware software does today, like check user mode applications or other things that are run later in the OS runtime environment after the load has been completed. The advantage of this is it's not possible for malware to install itself as a rootkit and not be able to be assessed by an anti-malware product that starts first. There's really a partnership here between Windows and anti-malware products. Windows gets released once in a while, and it needs to live for quite a long lifetime. But anti-malware products are more nimble in terms of they're aware of third-party pieces of code that have been released in the ecosystem. They're able to keep a list that's current of who's naughty and who's nice in terms of what policies it should enforce. And so by launching anti-malware software early in Windows 8, we're able to leverage the anti-malware product's capabilities more fully. The last piece of the secured boot puzzle is doing measurements during the boot process and being able to use them as evidence for the client later. So today, if you look at an OS like Windows 7, there are boot measurements recorded of the OS loader and the firmware in the TPM, but there's really an end to the measurement chain once the Windows boot manager starts. With Windows 8, what we're doing is we're extending that measurement chain up so it goes all the way over and covers the launch of anti-malware products as well as their policy. And the intent here is if you know the initial start state of a system and you know it's going to enforce policy because it has a good anti-malware product installed, you can infer the system is in a trustworthy state later. The anti-malware products are then able to gather up evidence from the TPM by getting a quote of the current TPM measurements and providing that to a third-party online service or something else that you want to prove the health of the client to. There's really a challenge here in terms of if you're using the TPM and you're recording measurements during the boot process, when do you stop? Right? Ideally, it would be great to record everything that happens on the system, every piece of software you run, and you would know exactly what state the system is in by being able to look at the measurements in the TPM as well as the log that goes with that. But the challenge there is that things start in different orders. There's timing conditions and things like that. So this is really a simplified model of how to do attestation on a client system because we record this initial start state and we really rely on the anti-malware product to do its policy enforcement. It's just not very feasible to record all measurements of everything and try to assess them. So this is, in some ways, a hybrid where not everything's recorded, but you're still able to establish trust in the client system by looking at its evidence. If you look at the overall architecture here, we've first got UEFI Secure Boot launching a trustworthy OS loader. Then we've got the launch of anti-malware software first, so it's able to enforce its policy. And then later on, because measurements of all that initial start state have been recorded in the TPM, anti-malware products are able to gather up a quote of TPM measurements and send those for remote verification and be able to prove the client is in a trustworthy state. So this is the overall secure boot architecture. It's also possible for this to be the starting point for other scenarios. If a client's gone through this process and an online service is established it's trustworthy, it could provision a certificate that could be used only if the system start state or the system state stays the same. Anti-malware products are able to do policy enforcement, but they're also able to say, this system is going out of policy. And what they can do in that scenario is there's an API that they can call in Windows that basically says, this client's no longer trustworthy, and we'll do some measurement extensions into the TPM. So if the client tries to do attestation later, it should be unable to pass health checks by the online service because there are these additional measurements in the TPM that say this client's no longer trustworthy. An example of when an anti-malware product might do this is, suppose the anti-malware product expects to get measurement updates or antivirus signature updates every 6 hours. If that update doesn't happen, it might say, this client's gone out of policy. If you've got a scenario where this is the launching point, where you provisioned a certificate that's tied to current TPM measurements, and the anti-malware product invalidates the client's health state, then that certificate is no longer usable because the TPM is able to create keys, like the key for the certificate, that's tied to policy, where the policy is measurements that are recorded in the TPM. So overall, we're really excited about this secure boot architecture. We think it's going to be great for customers. It's a partnership between Windows and anti-malware products. We've had some discussions with anti-malware product vendors, and we also expect to widen those discussions going forward before Windows 8 releases. The next thing I want to talk about is what features have we added to Windows that leverage the TPM. These provide customer benefits if they've made an investment in having a TPM on their system. The first one is network unlock for BitLocker. So you're probably familiar today with the Windows 7 BitLocker feature. There's a range of different protectors you can choose for BitLocker. You can choose the TPM only configuration. You can choose a TPM plus PIN configuration. You can choose a TPM plus PIN plus USB configuration. All of those have different security profiles in terms of the security they provide. Some of them are more resilient to different types of attacks than others. Many customers we've found are interested in the TPM plus PIN security profile, but they're frustrated because on every boot or for patching, customers have to enter the PIN value. The BitLocker Network Unlock feature allows a system to boot if it's on a physically secure network without any user PIN entry. The system needs to have native UEFI boot because this feature in Windows relies on the use of DHCP4 or 6 protocols to interact with the WDS server and get pretty much the equivalent of the PIN that a user might type in. If you have this type of configuration and you take the system off of the physically secure network, then you'll need to enter the PIN for roaming. But if you're on the physically secure network, you can do patching overnight. The system will boot all the way back up to the OS. Customers won't come in and need to enter their PIN for the boot process. So we think this is a great investment in BitLocker, and we're continuing to make improvements in BitLocker, especially for things that leverage the TPM. Another thing we're allowing is for the TPM to be used for certificate storage. So there's a lot of different uses for certificate storage. An example is email document signing. And what we've done in Windows is we've allowed you to configure the certificate template such that it specifies the TPM should be used to store the private portion of the certificate. The advantage of this is the key can be generated in the TPM for the certificate, and it's not able to go anywhere else. So software is not able to access the private portion of the key because it's protected from the running OS environment, and it's isolated in the TPM. You can also create a PIN or an authorization value for your certificate, and it will get the benefits of the TPM's anti-hammering logic. So if something tries to guess a bunch of authorization values, the TPM will say, hey, wait a minute, there have been too many authorization failures. You're going to have to wait for a time period until the anti-hammering logic isn't as angry in the TPM chip, and it will allow you to try to do authorization again. So if you were to have an infection on a system that had used TPM-based certificates, it wouldn't be able to export your credential information to another machine and use it. If your authorization information has a PIN value associated with it, the malware is unable to use brute force attacks to be able to discover what that authorization value is. So if you've done this and you have an infection, you could clean your machine, and access to those credentials would no longer be available to the malware. This is helpful if you're worried about scenarios like phishing attacks or things like that might create credentials and put them somewhere else and use them without your knowledge. If you're an application developer, we've tried to make this easy to use. You may have been familiar already with the Crypto Next Generation KSP interface. We've exposed the TPM as a KSP interface. So application developers familiar with doing crypto-based applications can use the same model, but get the benefits of the TPM hardware. Another feature is we've made the TPM so it will emulate a smart card. And this is called TPM-based virtual smart card. Basically, with the smart card, you have something in your possession. With the TPM, you'll have a TPM in your possession inside your laptop or your computer. So depending on what security properties you need, this may meet your requirements. And because the TPM, for all intents and purposes, with this feature, looks like a permanently inserted smart card, scenarios you use today, like direct access or even logging onto your system, are possible with the TPM-based virtual smart card. If you've got an existing investment in an enterprise in smart cards, you could transition some of those to use the TPM if you want to. Another thing I want to cover is how TPM provisioning and control has changed within the Windows OS. So with TPM 1.2, you may have experienced a process for provisioning where the user has to do something in the pre-boot environment to get the TPM in the right state to do something like turn on BitLocker, for example. With Windows 8, we're trying to change what that model is so the customer experience is a lot better. There's a new physical presence interface 1.2 specification from the TCG that we're advocating hardware manufacturers implement on their system. And it has a new flag in the firmware that basically says TPM provisioning can happen without any user involvement. What this enables the OS to do is to provision the TPM so it's ready for use without any pre-boot screen or customer interaction like that. So if you get a system out of the box for Windows, in the OS, we're simplifying the viewpoint somewhat in terms of it's either ready or not ready is the model we're looking for. And the TPM state may initially be disabled or deactivated. It most likely won't be owned at all. The Windows OS will check and see if it's able to provision the TPM without user involvement. And if it is, it will request that state transition. After the next boot happens, the TPM state will have transitioned to enabled and activated. And then later on in the same OS cycle, the OS will provision the TPM so it's owned and ready for use. The user is then in control because they can choose to turn on an OS feature that uses the TPM, or they can launch a TPM-based application. There's some information we're storing in the OS. We're storing the TPM owner authorization value in the OS. This way we don't have to prompt the user to save it. If you're in an enterprise environment, though, there's group policy settings that you can use to configure how much owner authorization is stored in the OS. There's actually a couple different things that we're able to store. One is the full owner authorization for the TPM. What you can do with the full owner authorization is you can reset the TPM's anti-hammering logic, or you can do almost any other scenario with the TPM. There's also an administrative delegation blob we're creating and storing in the registry in the OS, What this lets you do is administrative tasks. Like you could provision an attestation identity key that's used by anti-malware products to do attestation. We also have another delegation blob that's intended for what things we expect a standard user to be able to do with the TPM. All three of these can be stored in the registry. Depending on group policy settings, though, you can configure it so the full TPM owner auth is not stored in the local machine. This is useful if you're worried about anti-hammering protection being circumvented by the use of the TPM owner authorization value on the local client. All of this makes TPM management a lot easier for the customer. The TPM gets provisioned and ready for their use, and when they want to go use it, they can. They don't have to do extra reboots or things like that. If you're writing an application that uses the TPM, you might deploy your application on a Windows 8 OS, but it might have older hardware. If that's the case, we have some extra capabilities we've added in the OS that are a public interface you can use. Basically, when your application runs, you can check the TPM state. If the TPM is in a ready state, you can go ahead and use it. If the TPM is not in a ready state, there's an OS wizard your application can launch. That OS wizard will walk through the process with an administrator of getting the TPM so it is in the ready state and it's properly provisioned for the OS to use it. This presents a Windows UI for the user. If you'd like to have your own UI for the user as part of your application, we also have some APIs you could use where you can specify what properties or constraints you want to have on the provisioning process. You may want to have your application provision the TPM but not have any restarts happen. Or you might want to try to provision the TPM but not have any user interaction. If you want to, you can pass in those different types of parameters to our new provisioning API, and you can expose your own user interface in your application. So you've got a choice to do it either way. You can rely on the OS features to do provisioning for you if they're interactive with the customer, or you could tailor your own application with its own experience. The net result is, though, there's a lot of code that doesn't have to be part of your application, that's part of the OS, that's been tested. There's a lot of different start states the TPM might be in, and this will work through those and put the TPM in the right state for application and OS usage. The other thing we wanted to cover today was how we expect TPM hardware to evolve over time. So Windows 7 today supports TPM 1.2. There are existing TPM 1.2 applications out there. You're probably aware that the Trusted Computing Group is working on a TPM Next specification. Microsoft is calling that specification TPM 2.0 as opposed to TPM Next. If you have a Windows 7 TPM 1.2 application, it's probably sending direct TPM 1.2 commands to the device and getting responses back and dealing with those. This is the type of stack you're using. This stack still exists in Windows 8, but Windows 8 also supports, or we expect Windows 8 will also support TPM 2.0. There's an OS driver for TPM 2.0, and the Microsoft TPM stack has been added to support TPM 2.0. We're working with different hardware partners to try to bring about TPM 2.0 in the ecosystem, both as an integrated part or a discrete part, for different form factors and market segments. If you're a software developer and you're using the TPM, the higher level APIs for Windows, the key storage provider interface for certificate storage, for example, the application, the provisioning process, as well as the wizard for provisioning, and also the TPM-based virtual smart card, all work the same whether you'll have a TPM 1.2 on the platform or a TPM 2.0. There's an abstraction layer, and depending on what type of hardware is underneath, that abstraction layer for Windows will send the commands formatted the right way for either TPM 1.2 or TPM 2.0. We've simplified the implementation we'll support for TPM 2.0. There's the expectation TPM 2.0 will support different algorithms than RSA and SHA-1, but in Windows 8, we're only targeting supporting SHA-1 and RSA. So there will essentially be feature parity between TPM systems, whether it's 1.2 or 2.0, in terms of the OS feature set. If you're writing your application, we strongly recommend usage of these higher level APIs so you're not TPM device specific. Now we're going to go back to the demo. And the demo is actually using the TPM to store the certificates, as we talked about earlier. And the demo system itself is actually a platform that NVIDIA has allowed us to show you. It's an ARM-based system. It has a prototype implementation of TPM 2.0. The TPM 2.0 implementation leverages the trust zone environment on the ARM chip to provide a secure and isolated environment for the TPM functionality on the system. So, oh, yes. Let me switch to the device. I'm going to walk back through this demo and show you some more details about the certificates.
Okay, so now that we have heard all that what Rob had to say, this demo looks entirely different. While before we just authorized with a certificate that I guess some people assumed was a software certificate, now when we look at this, this is a hardware certificate that is held in the TPM, and the private key is only exposed to the trust zone side of the chip and not accessible to Windows. Also, when we perform the authentication here, we were asked to provide a PIN value. Now, this PIN value is not consumed by Windows, but is a baked policy into the TPM key at key creation. That means that if I have a key exposed to my system and I never provide the authorization value, no unauthorized person, even if it's an administrator, has access to the key material to use this certificate. This is very important because currently there is non-exportable and strong protected keys in Windows, but here now we have a policy enforcement in hardware that makes this guarantee really stick. When we go into the certificate manager, we can see that we have 2 certificates here enrolled, and we have in the certificate template specified that these keys are only supposed to be created on a TPM. And this one here, let me just move this over a little bit, if I only could. Well, this one here says with PIN. Here we have it. Can you see that? With PIN. So an user who would want to enroll for this certificate would have to provide a PIN to have extra level of protection on the key material. Imagine this is a user certificate for an SSL session where you provide your own second factor authentication just on your own machine. So when we go back into the context of IE, the authorization value that you give on the key will never transmit over the network. The only thing we see on the network is a client-side and server-side authenticated session. There is no unencrypted bit ever going between those 2 sites. When we look into the cert itself, we can see that we have a strong RSA 2048-bit key associated with this. This is available on TPM 1.2 and 2.0 for this matter.
Did you have to write any custom code to do this demonstration?
Oh, this is a very good question. Interesting enough, this client-side server authentication is available in Windows for a long time. So all the demo that we see here is not requiring any specific code. It was installed out of the build and just activated with the standard regularly pieces of code that we have. So by just specifying the TPM KSP in the certificate template, we enabled all this functionality on Windows 8.
So that was a demo of a prototype system that had TPM functionality available from within the OS. We're partnering with NVIDIA to try to make this system available for customers in the Windows 8 timeframe so they can benefit from its functionality. So, in summary, there's a lot of compelling scenarios that use the TPM in Windows 8. Expect TPM 1.2s and 2.0s on a wide array of platforms. What Windows 8 really provides OEMs is an ability to transition from TPM 1.2 to TPM 2.0 over the lifetime of Windows 8. There's also new application programming models exposed for the TPM that make using the TPM a lot less complex than it used to be in the past. It's easier provisioning. There's a smart card style interface. There's also the KSP style interface. We also covered the TPM-enabled features in Windows 8, the network unlock for BitLocker, and the automatic provisioning of the TPM, and the TPM-based virtual smart card, as well as certificate storage. There's some related sessions to this talk. The UEFI one already occurred earlier today, but this other one, Designing Systems for Continuous Availability, is something that covers the clustering aspect of BitLocker. So if you're interested in using TPM with the BitLocker, this may be a good session for you if you're interested in clustered environments. The network unlock feature for BitLocker is also useful for data center scenarios. And you might want to go to this talk to see more background about that type of context. There's some further reading you could do. If you're not familiar with TPMs that much, there are specifications for TPM 1.2 at the Trusted Computing Group's website. And there's also some links here at MSDN, which you've probably seen before in other talks. Our intention is to provide more information about the TPM features in Windows 8 over time on these websites, so you guys can have more details about how to use the TPM features, as well as more information about how things work. The floor is open for questions. If you could please go to the microphone, that would be great. If you want to shout something out, we'll try to repeat the question.
Hi. I have a question. In your presentation, you said the TPM is used after the OS loader, and I don't see the TPM can be used during the connected standby. Am I true? Am I correct?
Connected standby is somewhat similar to the system going to sleep. So the answer is yes. You could use the TPM before and after standby states. There will still be measurements in the TPM, and those will be present after you've gone into standby and come back out of it.
Oh, so from the OS inbox feature point of view, is TPM used for waking up in the connected standby?
No, in the connected standby case, the machine keeps all contents in RAM. BitLocker, for example, does not lose its key. BitLocker or the TPM would only get engaged again when you go to hibernation or when you shut down the system.
The entry into a low power state, like connected standby or into S3, which is sleep, is something that's up to the OS to record if it wanted to in terms of the industry standards. And we're not recording a specific event for entry into lower power state and exit from it with Windows.
TPM. I see. I understand. Thank you so much.
So can you comment about how TPM is used during runtime environments when, for example, do you use TPM for application isolation between Metro apps or during installation process? Essentially, what are the other usages which you use natively for during Windows runtime?
So there's a couple different things there. TPM is used during the Windows runtime environment in Windows 7 today, actually, to generate entropy and add it to the system entropy pool. So stronger keys are generated from the Windows cryptographic APIs. We are looking to support in Windows 8 the use of the TPM from the Windows PE environment as well. So if you were writing scripts or things like that for setting up a system, you could access the TPM from Windows PE, whereas that wasn't necessarily a supported scenario in Windows 7. Did we answer your question?
Maybe I can ask it. Go ahead.
There's probably a little bit more detail I could add, too.
That's fine. Let me just...
We do expect if you had an anti-malware product that validated the client's health, it may put a certificate on that system that gets used on a more continual basis to prove the health of the client. If you're doing online scenarios, for example, where the online service wants to validate the health of the client, use of a certificate may be something that's done on a more continual basis in the runtime OS.
Okay.
Let me add something to this too. Imagine that you have a system that you authorize with the virtual smart card, and you're running as a standard user. In order to install something, you need to authorize the installation. You can most certainly use your virtual smart card here, in this case again, to authorize the installation and acquire administrative privileges.
If you're using the TPM-based virtual smart card as well, you may, when you lock the system, if you're logging on with the TPM-based virtual smart card, that's an example of continuing to use it after the OS is booted as well.
Okay, thank you.
Sure.
Will Windows 8 support on-screen keyboard for startup pin entry on tablets that don't have a physical keyboard?
I think you're kind of asking a question about during the boot process. BitLocker
Right.
today with Windows 7 has TPM plus pin entry, for example.
Right, exactly.
There isn't going to be an on-screen keyboard that's part of Windows during the boot process. Although if you end up in a situation where the customer needs to enter the recovery key, my understanding is that Windows may go into the WinRE partition and boot that.
Okay.
And in that environment, you'll have some drivers available to be able to do on-screen entry of the recovery key.
Okay. Yeah, this is more for a startup pin, not really a recovery key, because we have this problem today with our tablets running Windows 7.
Right.
We have customers who want to use, the BitLocker TPM with startup pin scenario, and they're not able to do it.
I don't expect at this time that there will be a pre-boot Windows on-screen keyboard for pin
Okay.
entry for BitLocker.
Are there any other options for OEMs to do some custom?
You mean in terms of keyboards? Or
Yeah,
in terms
for
of
an
adding
on-screen
more
keyboard
security?
in that scenario, in the
Certain-
pre-boot scenario.
Certainly if an OEM wanted to implement what appeared to be a regular keyboard, that may be feasible.
Okay, because
Because in terms of the boot manager's interaction with the pre-OS,
right.
if it seems for all intents and purposes like there's a physical keyboard there, that may be sufficient. Although I think there's challenges of how the display would work if you've got an on-screen
Yeah,
keyboard. on top
I
of
mean,
the
we've
BitLocker
looked at
UI.
it. Yeah, effectively at that point, it's the OS bootloader that's in control.
Yeah, I think we're really looking at a scenario more where the profile for those platforms doesn't use a pin entry during the boot process.
Okay. Thank you.
Sure.
Could you come to the microphone, please?
Or we could repeat your question too, if
That's
you just
possible.
want to shout it out.
Yeah, try without. Usually it's loud enough. So that means BitLocker is still going to have that text-based UI. You don't have an on-screen keyboard and stuff like that.
So the question is if BitLocker is still going to have the text-based UI at pre-OS, and the answer is no.
Okay.
Since we're booting through UEFI, the BitLocker UI will also be in a graphical mode.
All right.
We'd actually recommend you try out turning on BitLocker on the system
Yes.
if you received one yesterday, and kind of look at what that user experience looks like. It looks a lot cleaner now, or at least we think it looks a lot cleaner.
Yep.
I couldn't quite hear that question.
Oh, no, I just tried to do that. As you know, when you enable BitLocker, you have to have an external key.
You mean you need to save the key somewhere, the recovery key?
Yeah. So
Yeah.
if you try it, make sure you got a USB stick nearby.
Sometimes I cheat by printing the recovery key to Office. I don't recommend that because you might lose your key, but on a development system, it might be an interesting choice. Yes?
And sorry, one more question. With the secure boot, I mean, you contrasted kind of, the BIOS boot with the UEFI boot, but the only difference in there is really that the UEFI boot would validate the OS loader. I mean, all the other steps should work really on both systems, right? Like the ELAM driver and measure boot and stuff like that doesn't really need UEFI, does it?
I think your question is, if I don't have a UEFI system that has secure boot, but I still want to leverage the features we articulated in secure boot, will some of them still work? And the answer is yes. We will still launch anti-malware software first, even if it's not a UEFI system. And we will still record measurements during the OS portion of the boot process, in addition to whatever measurements got made by the firmware. Generally, BIOS makes measurements, as well as UEFI implementations make measurements of firmware. So we'll continue that measurement chain up into the OS. So an anti-malware product could use BIOS measurements as opposed to UEFI firmware measurements to validate the health of the client as well.
The fundamental difference in this case is that while in UEFI you protect bad things from ever happening, in the BIOS world you let the bad driver in and you rely on finding it later. That's a fundamental security difference, right?
Probably one of the other things we should mention about the measured boot feature of secured boot is the OS is always going to let boot happen. Anti-malware products may have policy that wants to stop the boot process, and it's possible they could implement that. But in terms of measured boot and attestation, the OS just helps record measurements, and evaluation of those is done by an anti-malware product.
Okay, and how do you register the Trusted OS loader with UEFI?
The registration of the Trusted OS loader with UEFI is really an OEM provisioning issue from our perspective. Now, we'd like OEMs to ship systems that allow Windows 8 to boot. It's also possible that they might provision their systems so that other trustworthy OS loaders are also able to be launched. And it could be that some OEMs provide the ability for administrators to manipulate that policy, so other things that they want to launch are also able to be launched on that system.
The way UEFI identifies those entities is in first approximation by the signing certificate for the binary. When you read the UEFI 2.3 spec, you can also place the public key into a UEFI variable all the way down to the digest of an executable. The UEFI 2.3 spec gives in great detail the kind of policies that are possible to be defined in pre-OS that you will then be able to create a white or a blacklist that you can then express your policy in.
Just to simplify that a little bit, it could be the OEM provides a menu in their pre-boot screens that allow you to say, I like this OS loader. I would like it to be able to boot on my platform. And I've entered whatever administrative credentials I need to identify that I'm the owner of the platform, or I'm physically here and I'm permitting this to happen. Maybe authorization enough. And you could have other things boot as well. But those are really OEM choices about what type of functionality they want to provide for configuration of UEFI policy.
I think we're going to see some differentiation in value where OEMs are going to take this to the next level in order to express this policy. But from a sheer spec point of view, it may be an enterprise thing where a certificate policy is pushed down from a central server all the way to an expression of, the bootloader just ran through, I like, please only boot this in future.
Okay.
Will that be like a requirement for OEMs to provision TPM if it's available on board?
The question is, will there be a requirement for OEMs to provision a TPM? So I think today we're really trying to stay away from OEM requirements and really talk about the customer value in having a TPM be present. And so I think we've really tried to put the features there to drive customer demand around the TPM. And we think it's beneficial to have TPMs present in lots of places, so we're strongly encouraging partners to place those on their system.
There's also an added benefit for end user machines which historically have not had a lot of TPMs exposed. With a feature like the virtual smart card where you can use your home machine now to enroll it in an enterprise to RAS into your company or can use this virtual smart card, for example, in an online.
I'm not sure RAS is a term.
Oh, sorry.
Direct access.
Direct access,
might be a
I'm
better
sorry.
Example.
But also in an online banking scenario where the bank would love to give you a smart card, but they shied away from rolling out the cost for a smart card reader and all that stuff. Windows 8 will address this because it just comes in box.
Your question is, what about support for the TCM? Windows doesn't have any OS features that use the TCM, but Windows does support the TCM like any other unclassified device. So third parties could write drivers that access a device as far as Windows is concerned. Those could be signed and distributed and be used. I would more say that Windows 8 supports the TCM, but there are no OS features that use the TCM. Is your question, do we have plans to support within the OS similar features that would leverage the TCM? I think what Microsoft's position is we would like to see more open participation from all kinds of parties in the Trusted Computing Group and have an industry standard that's a global standard like TPM 2.0 that's inclusive enough to support the needs of a wide variety of geographies.
And in the implementation of Windows 8, we have just now begun supporting the support of TPM 2.0. Obviously, when you would take a look into the TPM 2.0 spec, you'll discover that there's a multitude of more algorithms that are currently not exposed, but Windows is dedicated in following down the trusted computing model.
We're certainly supportive of the specifications from the Trusted Computing Group and open standards, global open standards. Yes?
So will BitLocker support pre-boot authentication with physical smart cards?
I don't believe there are any plans to have BitLocker support pre-boot authentication with physical smart cards.
This is not so much a Windows decision as it is an infrastructure firmware decision, right? BitLocker would have to consume a smart card stack that would have to be provided by either UEFI or BIOS. And since nothing like this is openly published, especially for smart card, you need a different card module for each different smart card you have. The vendors of the smart card would have to open up their little smart card piece in the smart card stack. So the likelihood of a pre-OS authentication with a smart card in the given environment as we have it today, I think, is rather little. But it's not so much that we don't want to do it, it is the infrastructure is not there.
Yes? How about you in about the fifth row there, please?
I have a confirmation. Windows 8 support TPM 1.2 and 2.20. And I have confirmed Windows 8 only use RSA and SHA-1. And no other product cryptograph algorithm which Windows 2.0 support. Is this correct?
That's correct.
So the question is, will Windows 8 support other algorithms for TPM 2.0 other than SHA-1 and RSA? And I think the answer is the inbox features we're providing in Windows 8 will only support like the abstraction layer for SHA-1 and RSA.
So including command set, right? Only use 1.2 command set.
No.
In some respects, the question is about what type of command set is used with TPM 2.0. I think that's actually a question we might need to follow up offline about, just because there are some restrictions about disclosing information from TPM 2.0 in a public forum. You had a question?
Can the security fluid function work without TPM hardware?
So is the question how much of secure boot, for example, or other things we've talked about today work without a TPM on a system? So if you had a system without a TPM, you could certainly have secure boot, where firmware enforces launch policy for the OS loader. You can also have the early launch of anti-malware products, but you wouldn't have that third piece of secured boot, which was measurements recorded during the boot process and being able to be used as evidence. BitLocker also can work if it's configured differently than the default without a TPM, with like a USB stick, for example. So there are some things about BitLocker that could be used. But you wouldn't be able to use BitLocker network unlocked, for example, because that does rely on the TPM. And you couldn't use TPM-based certificate storage or the TPM-based virtual smart card either.
Will you check the offline loader without
I think, is your question, Is your question, is it expected that the boot time of a system will be longer if it has a TPM? The answer is yes. Boot time is expected to be longer on systems with the TPM because there's some extra work to measure the firmware components during the boot process, record configuration information, and also there would be extra time added for the OS to do measurements in the TPM as well for OS components and the early launch anti-malware software. That's correct. A lot of great questions. Another one?
For Windows 8 slate or tablet devices, is TPM implemented as hardware or firmware?
How a TPM implementation gets done is really an implementation choice by the platform manufacturer.
So will you support FTPM?
We're looking to be able to support different types of TPMs on different platforms per hardware vendors we're partnering with. Maybe the right way to answer that question. Yes, in the red shirt?
Well, actually, I'm working on Trusted Platform. And what is the minimum requirement for TPM? Do we need to support both 1.2 and 2.0?
I didn't quite hear the first part of your question. Could you repeat it, please?
I'm working on Trusted Platform, actually ARM-based platform. So I read some requirement is that a minimum requirement for TPM in SOC platform is 2.0. But in the figure you showed, we need to support 1.2 and 2.0 at the same time.
I think, well, let's see. So if the question's about requirements for Windows certification, I think we'd prefer to talk about those offline. In general, though, we're only expecting a platform to have either a TPM 1.2 or a TPM 2.0 implementation. Where the OS isn't able to do resource management for both a 1.2 TPM and a TPM 2.0 at the same time. It needs to have one device or the other device in terms of what's exposed to the OS.
I'm sorry, I'm not a TPM expert. Does TPM 2.0 cover TPM 1.2? Is totally different than command set?
There are significant differences between TPM 1.2 and TPM 2.0. TPM 1.2 is very SHA-1 specific and RSA specific in that it only supports those algorithms. And so the TPM 2.0 functionality is significantly distinct.
This is one of the reasons why, at this point, we're concentrating on RSA and SHA-1 because this is the common denominator between both devices.
We're really trying from the OS perspective to provide the same feature set for 1.2 and 2.0. Yes?
For all these features with TPM and BitLocker, is that going to be in all versions of Windows 8 client? Or only specific?
So the question is, what versions of Windows will have what features? And unfortunately, at this point in time, we're not able to answer that question. That's still being formulated. Yes?
Sort of related to that, but a little bit different. Like right now with Windows 7, in order to utilize TPM, I have to turn on BitLocker.
If the question is, do I need to turn on BitLocker in Windows 7 to use the TPM? The answer is no. There's no dependency on using BitLocker to use the TPM for other features. For example, on Windows 7, if you had your TPM enabled and activated, it would still be used to generate entropy for the system, even if BitLocker wasn't on.
BitLocker in this regard is as any other consumer of the TPM, so there's no strong dependency backwards to BitLocker here.
Are there questions in that back corner? It's a little bit hard for us to see people there. Okay. Any other questions? Yes, sir?
Is pin-based logging available for local accounts?
Sorry, I didn't catch this at all.
Is pin-based logging available for local accounts?
Pin-based logon. Pin-based logon available for local accounts. When you start using virtual smart card, you are authenticating with a certificate against an enterprise, correct? Now, when you create a key and attempt a certificate-based logon against a local machine, there has to be something validating your credentials. So in that matter, the answer is no. But it is absolutely possible to write a credential provider that will use the TPM KSP to encrypt your local password with the TPM and replace your password with a PIN.
So is that
the capability of supporting such a credential provider is there.
What about log on with live ID? Will that also support pin-based log on?
I think
We're not experts on the log on with Windows Live ID, so we may need to follow up with you afterwards and find a contact who could answer that question.
For your early launch capability, is that before the disk drivers load, or
Yes.
are there, okay.
The early launch anti-malware software would actually start before the storage driver is available.
Okay. And the UEFI is responsible for doing that load?
WinLoad is invoking all the drivers from the disk using UEFI, the driver stack. The initialization of those drivers happens after the kernel is initialized. And the initialization of those drivers happens after the AV driver is initialized. Therefore, if WinLoad happens to load a bad driver, the AV driver will have a veto power that says, I don't want to initialize the bad driver because I recognize it to be bad. The important distinction here is that with that capability, from the moment somebody presses the power button on the machine, there's a record created that the AV product will be able to inspect before it allows further drivers to be loaded. And the authorization for each succeeding load after that will then be resting in the AV driver's hands so they can ensure that no bad things are getting exposed to the system.
You may have mixed that answer with both the measure boot feature and also the early launch of anti-malware software feature. So the way the boot process works is WinLoad will use the UEFI environment's drivers to load up all the boot start drivers as well as the early launch anti-malware software. The WinLoaded executable then calls exit boot services, which shuts down the UEFI interface that could be used to access the drive, for example. And then it carefully orders what's going to run next. And it places the order higher for the early launch anti-malware software. So it's able to start, register some things, so it's able to do policy on later drivers that get initialized or don't get initialized based on what it says. And so that's how the early launch anti-malware piece functions. And there is a record potentially, if your system had a TPM, of the order in which those things were launched during the boot process.
Ideally, you want to use all those things in conjunction together to get the maximum security out of this.
Any other questions? Yes?
In the case of the eDrive, do you still need TPM for BitLocker?
I believe for eDrives, BitLocker will be set up with the same configuration or profiles that you have choices of without an eDrive, using software-based encryption. So you could use an eDrive, I think, with TPM only, TPM plus PIN, USB only.
The eDrive will only take away the chore from the system that is the filter driver currently, who will encrypt and decrypt the blocks that come from the drive. The eDrive still is going to needing to be seeded with a key. And in this case, or in the BitLocker case, the key is protected potentially with the TPM or coming from a USB stick or whatever mode you choose. So the key storage aspect is not affected by the choice of drive that you're using.
We could certainly follow up with you afterwards and find out a specific answer from the storage team too on that question. Well, you've been a very kind audience. Thank you for your time.
Thank you very much.
Attending.